Chapter 3-5, practice A and B, 30 and 32, method of your choice. Problems 33 through 41, odd must be done by substitution. Now, folks, I'm telling you right now, I have drastically reduced the amount of problems that I had once considered assigning you. So I need your undivided attention, and I need you to pay attention to the whole period. Are we ready? Problem number 34. I am doing problems directly out of your textbook so that you have a clue on how to do things. You need a brain to remember your pencil because I'm not your mother. Girls, flip flop, zip it. Okay, now we're doing substitution. When is the best time to do substitution? When is the best time to do substitution? I'm sorry? Well, you can always solve for any variable. But when is it best to use substitution? When the variable has a coefficient of what? No, but Mrs. Irvin does.
Does she?
Yes.
All right, thanks.
Thank you. Okay, so now, x plus 2y plus z is equal to 4, 2x minus y plus 4z is equal to negative 8, negative 3x plus y minus 2z is equal to 1, negative 1. Here's a 1, here's a 1, here's a 1, here's a 1. Do we see that? So I have lots of coefficients of 1. Now what I need to do is figure out which of those equations do I want to choose and then solve for which variable. We're not doing elimination. If I were to be doing elimination, I would want to eliminate y. But today it's all about substitution. So since it's all about substitution, you have to figure out which one are you going to solve for and then use that expression and all the other ones. So which equation do you want to use? Let's make it really easy, and let's do equation 1. And if I make it really easy, which letter do you want to solve for? X or Z? X. So if I'm solving for X, I have X plus 2y plus Z is equal to 4. Now every place, I have to get everything that's on the same side of the X on the opposite side. So what has to go away? 2y and Z. So I'm going to subtract 2y and I'm going to subtract Z. And I'm going to do that in one step. So I have X is equal to 4 minus 2y minus Z. Done. So now every place that I have an X, what can I plug in? 4 minus 2y minus Z, right? So now I've used equation 1. Now what do I have to use? I have to use equation 2. So equation 2 is 2x minus y minus 4z is equal to negative 8. And what am I plugging in for z? Or for x, sorry. The 4 minus the 2y minus z. So I have 2 times 4 minus 2y minus z plus y minus 4z is equal to negative 8. Do you see that? Yes or no? Now what do I do? Oh. Well, that was easy. It's minus y. And it's plus 4z. Y'all didn't catch that one, did you? It is minus y plus 4z. Sorry. Okay, do we all see it now, yes or no? Okay, so now I'm going to distribute. So this is going to be 8 minus 4y minus 2z minus y plus 4z is equal to negative 8. What should I do? Combine like terms. So I have 8 minus 5y plus 2z is equal to negative 8. I do? Yes? I should subtract this 8. So if I subtract that 8, I'm left with negative 5y plus 2z is equal to negative 16. Yes? We good? Okay. Now, next. What equation have I not used yet? I have not used equation 3. So equation 3 is negative 3x plus y minus 2z is equal to negative 1. And what do I plug in? Vx. So this is going to be negative 3 times 4 minus 2y minus z plus y minus 2z is equal to negative 1. Yes? Okay, now what do I do? I need to distribute. So this is going to be negative 12 plus 6y plus 3z plus y minus 2z is equal to negative 1. Now what? I need to combine like terms. So this is negative 12 plus 7y plus z is equal to negative 1. Add the 12. 7y plus z is equal to 11. Box it in. Now look at the 3 boxes that I have up there. To the 3 boxes. If you look at my 3 boxes, what do you notice? The one is solved for x, and the other 2, the red and the green, have exactly the same variables. Since they have exactly the same variables, you are going to put them on top of each other. And from this point, you can use elimination, substitution, or Kramer's rule, whichever one you want. Now you tell me, what would be a really easy method to use on here? Elimination would probably be easiest. So if elimination would probably be easiest, what am I eliminating? Y or Z? Z. If I'm eliminating Z, what do I need? I need a plus or minus 2. Do I already have a positive 2Z? I do. So what else do I need? I need a negative 2Z. So I'm going to multiply this one by negative 2. So I recopy the negative 5y plus 2z is equal to negative 16. I distribute this one right here. And then I add straight down. So this is going to be negative 19y is equal to negative 38. Now what? Divide by negative 19, and y is equal to 2. Now I found y. Now what should I find? I'm going to go over to the red equation, the red box, and I'm going to plug in what I know, because I want to now find z, correct? So I have 7 times 2 plus z is equal to 11. So 14 plus z is equal to 11. Subtract the 14. Z is equal to negative 3. I found y and I found z. Where do I go to get x? I would go back to the box or to one of the original. It does not matter. Do we all see that? So I'm going to go back to the box, which is x is equal to 4 minus 2y minus z. X is equal to 4 minus 2y minus z. Is that what I said? And I plug in what I know. I know what z is. I know what y is. So 4 minus 2 times 2 minus negative 3 minus the negatives a positive. 4 minus 4 plus 3 gives me 3 is my x coordinate. So what is my POI? My point of intersection is going to be 3, 2, -3.
Can you go to your first example?
I probably changed everything.
The first one you did in the old one is just drawing fractions, and
Like number 36.
that might be the one I'm doing. I don't know, but I'm doing I open your notes and I'm doing those examples, and I'm like, oh my gosh, this is just
Okay.
On the next one, can you slow down a little bit? Just want arms right now. I'm not understanding.
Okay. Yes. What I'm going to do is I'm actually going to do it on the other board. I know that the people who are going to be over here are not going to see it, but I think you guys are going to do better if I do it on that whiteboard. Okay? So there's my point of intersection. Now, I want you to copy 36 down for me. Okay. Now, look at problem 34. Or 36, sorry. On 36, what you're going to notice is that it has what in it? It has fractions in it. Do you guys like fractions? So what should you do? You should get rid of them. And how do you do that? So you're going to multiply this entire thing by what? By 12. So that means my equations that I'm looking at are going to be 2y, 3y minus 2z is equal to 0. And then 2x minus z is equal to -2. Do we all see that? Brittany, what's up? What did I do? 12 divided by 4 is 3. 12 divided by 6 is 2. Are you with me now? Are you sure? The other ones I just recopied. Is everyone good?
So wait, you divide 12 divided.
Remember when you have a fraction, I take the number and divide it by the denominator and then multiply by the junk that's left? Okay? The junk is just the numerators. Okay, so now I'm using these three equations. So I'm going to go over to my regular board today, and I'm going to show you over here. And I'm just going to bring these down. Okay? So there's our three equations. Now, if you're looking at those equations, you tell me. Remember whenever we were doing this last week with two equations and two unknowns, that I told you to box in the one that had the one equation left, right? And we liked it. It was helpful. Why was it helpful? Because it was already done for you, right? Okay, so we're going to think about that a minute. Look at this. If I choose this equation, what does that mean I don't have in it? X. Which means when doing substitution, I have to solve for what? X. So if you want to solve for X, look at the coefficients. 6x and 2x. When you use substitution, do you want to solve for variables that have coefficients that are not 1? No. So what does that tell me? Do I want to use the 3y minus 2z as one of my equations? No, I do not. So I'm going to go back, and I'm not going to even consider that. What I'm going to now consider is the 2x minus z. Well, if I use the 2x minus z, what's missing?
Y.
The y is missing, which means what am I solving for when doing substitution? The y. So let's look at the coefficients on the y's. 1y and 3y. Is that nicer? Yes. So what does that mean? Which equation am I taking and solving for y? I'm going to take equation 1 and solve it for y. Why would I do that? Because I'm sorry? Because the coefficient of it is 1. And since the coefficient is 1, that's the equation I'm going to choose. So I'm going to take equation 1 and I'm going to solve it for y. And again, I'm on the other board for those people watching it. Right? So if I solve this thing for y, what do I get rid of? The 6x and the 4z. Okay, that's gone. The z's are gone, so I have y is equal to negative 8 minus 6x plus 4z. And what do I do with that now? I'm going to box that in. So I'm going to have y is equal to negative 8 minus 6x plus 4z. Okay? Now that I have what I've used as equation 1, I know I'm going to box in equation 3 because why? Equation 3 is already done. It already has just x's and z's in it. So equation 3 has been used. What has not been used yet? We have not used equation 2. So now we're going to use equation 2, correct? And what's equation 2? 3y minus 2z is equal to 0. In every place I see a y, what plugs in for that? Exactly. So I have 3 times negative 8 minus 6x plus 4z is equal to 0. And what do I do? So negative 24 minus 18x plus 12z is equal to 0. Now what? Add the 24 to both sides. Aw, I hate it when I do that. I forgot that after the parentheses. Sorry, guys. So I forgot the 2z after the parentheses completely. Thank you. Negative 24 minus 18x plus 12z minus 2z is equal to 0. Combine like terms. And that's going to give me negative 24 minus 18x plus 10z is equal to 0, right? Add the 24 to both sides. Negative 18x plus 10z is equal to 24. Box it in. Okay? Now what do you notice? I have y is equal in one box. My other box, I have negative 18x plus 10z is equal to 24. In another box. So look at the 2 boxes in black up on the board up there. I have x's and z's in them, right? So now I'm going to take those 2 equations, put the x's and the z's in them, which is negative 18x plus 10z is equal to 24. And then my original one, which is going to be 2x minus z is equal to negative 2. And what do you think I'm going to do? I have it down to 2 equations with 2 unknowns. I can do any method I want. Elimination, substitution, or Kramer. So what do you guys want to do? And what do you want to eliminate? So if you're eliminating z, I have to have plus or minus what? 10. So what am I going to multiply what by to get plus or minus 10? I'm going to multiply the bottom equation by 10. So I bring down my top equation. I distribute to the bottom one. And I'm going to add straight down. So this is 2x. That's gone. Is equal to 4. So x is equal to 2. So now that I found x,
Wouldn't that be -2, -4?
No. Because the 24 is positive. Are you with me?
Yeah.
Okay. So x is 2. So now that I found x, what do I find? What can I find?
Or Z.
Which one do I have to find first, y or z? I have to find z first, because y has both x and z in it, correct? So I have to find y, so how do I find y? Or not y, z. How do I find z? So I'm going to go down to one of my equations. Does it really matter which one? It really doesn't matter, but I'm going to tell you right now. The negative 18x plus 10z is far bigger numbers than what the original problem was, which was 2x minus z is equal to -2. And I'm going to plug in what I know. So x is 2. So 4 minus z is equal to -2. Subtract the 4. Negative z is equal to -6. Z is equal to +6. So I found x and I found z. And how do I find y? I need to go back to my blue box. Y is equal to -8 minus 6x plus 4z. -8 minus 6 times 2, which is x, plus 4, and z is 6. Yes? Is everybody with me? I got this right here, Marissa, from this. I originally solved for y on equation 1. Now I'm plugging back into equation 1 what x and z are. No. I plugged in there, and I plugged in there. You see that?
Yep.
Okay. So that's going to be -12, -8 minus 12 plus 24, -20 plus 24. So y is equal to 4. So what's my POI?
2, 4, 6.
2, 4, 6. Who do we appreciate? Math. 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 No? Let's try it. Now, I'll be honest, I hate substitution. It is extremely long. It has its usefulness when it's solved already. Okay? This process was very, 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 very long for no apparent reason whatsoever. But it did get you your end result, right? So tonight, what do you owe me? You owe me this. Now, I want to talk about problems 30 and 32, so get your textbooks open, please. So, if we're doing that, let's take a gander on page 172, and let's work on problem 30. In a factory, there are 3 machines, A, B, and C. Machine A, machine B, machine C. So how many equations should I have?
3.
Why? There's 3 variables. Okay? When all 3 machines are working, they produce 287 volts per hour. So if they're all working, that means they're all working together. So what's an operation would be together? Adding. So what is my first equation?
A plus B plus C.
Is equal to 287. The next sentence says, when only machines A and C are working, they produce 197 volts.
A plus C.
A plus C is equal to 197. The last sentence says, when only machines A and B are working, they produce 202 volts. So A plus B is equal to 202. There's your 3 equations. You may use any method you want. Okay? Now, number 32. A stadium has 49,000 seats. Seats sell for $25 in Section A, $20 in Section B, and $15 in Section C. The number of seats sold in Section A equals the total number of seats in Section B and C. So what's my first equation?
A equals B plus C.
A equals B plus C. That's one equation, but there was one before that. There's 49,000 seats. It's just like your machine, right? A seats plus B seats plus C seats is equal to 49,000. And the last one is, suppose the stadium has $1,052,000 to the sold-out event. Well, each seat is $25 in seat A, $20 in seat B, and $15 in seat C. So then that's going to equal $1,052,000. Sorry. There's your three equations. I would use substitution. You may leave.